Good morning, Geometry iPad Initiative students. This is Mr. Lane coming back at you after your spring break for Section 9.3 Composite Figures. All a composite figure is a figure made up of different simple shapes such as triangles, trapezoids, circles, parallelograms, so on and so forth, all the figures that we've been dealing with. What we're going to do today is we're going to find the area of those different composite figures. So make sure you answer question number 5 in your notes. Make sure you get the title down and you can read through the objective and the why. Remember, we need a half page of notes as always, and your summary at the very end of that. So let's go ahead and get started. Here's your formal definition of a composite figure, and I think we're going to jump right into the first example here. So the first example looks like we've got, and usually this line's not going to be here, so kind of imagine if it's not there. Alright, so we've got, almost looks like two rectangles making up one figure here. So if we just find the area of the first rectangle right here by taking 25 times 30, base times height as always, then we'll have the area of this first rectangle. It looks to be 750, so I'm going to write that in there right on that rectangle, 750 inches squared. And then let's see, this little rectangle right here, the full length looks to be 50, and then the top looks to be 25, so that's going to leave 25 left here. So if we multiply 25 times 10, that's going to give us 250 inches squared, which if I add the 750 and 250, that's going to give me 1,000 inches squared for that composite figure's area. So there's the first example. Let's move on. Looks like we got another composite figure. This one's made up of 3 different shapes. Looks to be a half of a circle, looks to be a rectangle here in the middle, and then a right triangle up there on the top. So let's go ahead and figure up the area of this composite figure. Let's just do the middle rectangle here first. So if I take 9 times 3, that's going to give me 27 foot squared for the area of that. And then the top little triangle here, remember that's 1/2 base times height. So the base is 9 and the height is 4. So if I cancel out the 4 with the 1/2, that's going to leave me a 2. 2 times 9 looks to be 18 foot squared. And then the bottom half of the circle, well, the area of a circle, the formula is pi r squared. So let's see, the full distance across would be 9, so our radius would be half of that, which is 4.5. So I got to take 4.5 times the pi key. I don't know if my little video calculator has the pi key, but yours probably does, so I recommend you use that. So I'm going to put 3.14 times, let's see, I got to take my 4.5. I'm going to clear that. Alright, let's go 4.5 times 4.5 times 3.14, and that's going to give us the area we need, 63.6. And that would be if it was a full circle, so we got to take half of that. So let's just take that answer and divide it by 2. And that's going to be 31.8 feet squared. So I got to add 18 feet squared, 27 feet squared, and 31.8 feet squared. So let's do that real quick. It'll be 31.8 plus 27 plus 18. Bada boom, bada bang. Looks like we've got a little 76.8 feet squared. And that's how you find the area of a composite figure, regular geometry students. There you go. iPad Initiative students, always on the Lumen website. Alright, so in this one, looks like this is going to be a little different because now we've got to figure out the shaded region. Looks like we want to figure out the total area of the triangle minus the area of the circle. And by the way, secret word time. Secret words for this lesson will be Kleenex. So first one to send that to me gets 2 points as always. I hope that's you. Good luck with that. Alright, so we've got, let's see, a base of 12. So we're going to take 1/2 base times height. So let's see, half of 18 would be 9. 9 times 12 would be 108. So the area of the triangle, if it was just a complete triangle without the hole, would be 108 feet squared. Now we got to figure out what the area is of this circle and subtract that from the total area. So again, it looks like my radius is going to be 4.5. So 4.5 times my pi, or 4.5 squared times my pi. So 4.5 times 4.5, and then times 3.14 equals, and then we got to take half of that because it's only half a circle again. So that's going to be my 31.8. So now I need to subtract the 31.8 from the 108. So 108 minus 31.8 equals, looks to be 76.2 feet squared. Notice I'm always labeling my units in feet squared on area to get my final answer. Alright, looks like we have a little trapezoid setting in this circle. So again, we want to find the area of the circle minus the area of the trapezoid, and that will give us the area of the composite figure. So let's do the circle first. It looks like my radius is 10. So pi r squared. Hopefully you're learning these area formulas. We've been using them enough here lately that some of them hopefully are sinking in. So I got to multiply 3.14, so that's going to be 314 feet squared for the area of the circle. Alright, now the trapezoid's formula is B1 plus B2 times the height divided by 2. So let's plug that out real quick. Looks like my B1 is going to be all the way across here would be 20. So I'll have 20 plus, it looks like the B2 is going to be the 10 foot. And then the height is 8 foot. And we got to divide that by 2. So I got 30 times 8. 30 times 8 would be 240. Divided by 2 would be 120. And that's what we're going to have to subtract from the 314. So let's subtract that real quick. And we'll have 194 feet squared for the area of just the shaded region there of that part of that circle. Alright, let's move on. Regular geometry students, there you go. Let's crank this thing on to the next example here. Alright, here's the next example here. It says a company receives an order for 65 pieces of fabric in the given shape. Each piece is to be dyed red. The die is 6 inches The die is 6 inches squared of fabric. This should be 2 ounces of dye is needed. How much dye is needed for the entire order? Alright, well, this is one piece of fabric. We got to figure out how much fabric we have for just one piece. Multiply that by the 65, and then I think we can dye it by the divide it by the 6 that we'd need for and then actually we need to multiply it by the 2 ounces for each one of those. So quite a bit to do here, but let's go ahead and just figure out the area of our heart right here. So let's do that first. So it looks like we have a square right here. Square, we just multiply side times side, so that's going to be 9 inches squared. And then it looks like these are going to form one circle. It looks like the radius is going to be a 3. The diameter is going to be a 3, so the radius would be a 1.5. So we've got to square 1.5 and multiply it by 3.14. So let's go ahead and break out a calculator here. Okay. So let's see, 1.5 times 1.5 equals, then we want to multiply that times 3.14, and that's going to give us 7.1 is what we'll go with for the entire circle. So if we add 9 onto that 7.1, that's going to be 16.1 inches squared for one piece of fabric. Well, we have 65 pieces of fabric, so we're going to multiply 65 times the 16.1, and that's going to give us a total for the total order will be 1,046.5. Okay. Well, for every 6 inches of that, we need 2 ounces. So we're going to go ahead and divide that by 6, and that's going to give us 174.4 6 inches that we need. So we need to multiply that times 2, and we'll have how much dye is needed for the entire order. So 348 ounces of dye. Alright, regular geometry students, bada boom, bada bang, there you go. Let's cruise on here. Alright, looks like we've got one last example here. We're supposed to estimate the shaded region here. It's on a graph, and each one of the little squares is 1 foot. Couple different ways we could do this. We can try and break it apart into different shapes. That's most generally the direction that somebody would go on this. So for instance, what's the best way to divide this one up? We could go here, I think. We could get a big square in here. Looks like a triangle in there. What we got? Some sort of trapezoid in here, and then looks like maybe a triangle right here. So let's do this one first. Looks like a right triangle with 2 as a height, 1 as the base. So we'd have 1/2 times 1 times 2. So the 2's are going to cancel out. This is going to be about 1 foot squared here. This little rectangle right in here, let's do that next. We've got about 1.5 times 1, 2, 3. So 3 times 1.5 is what we're looking for there. So this one here is about 4.5. So I'm going to write it down here because we're going to add all this together. So we've got this and this area done. This is another kind of, I mean, we could do a circle right over here, but I think this is pretty much looks like another rectangle to me. So I'm going to say this length is 2 and 3 by 1, so 3 times 1 would be about 3 foot. And this is an estimate. We're not going to get the exact here on this. Right here it looks like we got another triangle. Looks like the height is going to be 1, the base is going to be 2. So again, that's about 1 foot because that's the same dimensions as this other triangle. And this, I think we got a trapezoid here, similar to a trapezoid. We're going to overestimate just a touch here. So I'm going to count the first base. 1, 2, 3, 4, 5. Plus my base 2 is only going to be 1. Looks like what? 1, 2. Times my height of 1, 2.5. And then that's all divided by 2. So I got 7 times 2.5. So This is Mr. Lane signing off from OHS High School. Have